Welcome to the All Turtles Podcast, a show about entrepreneurship and AI. I'm John Cifuentes, co-founder at All Turtles. Today, my co-host Jessica Collier and I interview Adrian Kaehler. Adrian is an expert in robotics, computer vision, and machine learning, and he's the co-founder of the Silicon Valley Deep Learning Group. He has a unique perspective on how deep learning research has evolved and how to bring these researchers and developers together to advance the technology. Then Phil Libben joins Jessica and I to talk about an AI use case in which an AI-powered car almost causes Jessica to miss her flight. And we answer a listener question about algorithmic bias. Hey there, Adrian. Thanks so much for joining us. We are here with Adrian Kaehler, who works in robotics, computer vision, and machine learning.
Hi, Adrian.
Hi, it's nice to be here.
Great.
Thank you for inviting me in.
So you've been a really kind of key voice, especially in this large Silicon Valley deep learning group. You know, for our listeners, can you talk about that community a bit and kind of what it is, what you guys talk about, what types of events you put on, maybe if there's something coming up that we can engage with?
Sure. So the Silicon Valley Deep Learning Group is a professional community. We started out in about 2013 when deep learning was not really a well-known thing outside of perhaps the computer vision and speech recognition communities. I was myself doing work in that space, and I realized that it was very difficult to hire people in 2013 who were doing deep learning because there was just a tiny trickle of people who were coming out of universities who had been studying this previously esoteric topic for many years. And it was very difficult to hire this tiny trickle of people who were mostly going to, Google or other very large employers that had a lot of money to attract them and a lot of special opportunities.
So for once, it really was a pipeline problem.
It really was. But what I realized was that there were a great amount of interest in the community in this topic beginning to develop among professional software developers. So what was happening was that a lot of people who were already, mid-career software developers, relatively sophisticated people, they were interested in this and they were kind of self-teaching themselves and laterally moving in towards deep learning and other emerging AI technologies. So what I became interested in at that time, I was head of software for Magic Leap Corporation, and I was very interested in hiring, more people who had this skill set, and I was looking for ways to hire them. So when we created the Silicon Valley Deep Learning Group, we created what was to be a resource for people who were not necessarily the deep academic experts in that emerging topic, but people who were mid-career professionals and people who were learning about it in a kind of lateral way. So the Deep Learning Group was, if you like, kind of styled after the homebrew computer club,
Sure.
of ancient fame. And our idea was to really bring together people who were of many kinds. So there were lots of engineers. To this day, it's a majority engineers. But there's a great number of people who are entrepreneurs or investors or media people who are interested in the topic and the subject and want to learn about it. Because we started in a time when there really wasn't much going on in deep learning, the group grew very rapidly and has a sustained growth for quite some time. So it's now approximately 6,000 members. We have events every month. We have speakers come and give talks, and we have kind of social time before and after the talks. So we try to combine, if you like, a kind of professional networking service with ongoing education for everyone involved by bringing in speakers who are either technologists, engineers, or founders of companies that rely on deep learning as their core technology, and so on. Sometimes investors. We've had panels of investors who focus in deep learning technologies, this kind of thing.
Can you talk a little bit about what the non-technical folks in the community bring to the table?
Sure. Well, what's happened over time, and I can't really claim this was intentional, but the emergent property of the Silicon Valley Deep Learning Group was that because there was this very heterogeneous mix, and because let me digress for a moment, a lot of the mid-career professionals that I referred to were actually having a lot of trouble doing deep learning professionally because they were currently employed working for company X doing something that they were that their company was happy paying them to do. And they said, well, we would like to do this. And even if you work for a company like Google or Microsoft or Amazon that is doing a lot of work in deep learning, in 2013 or 2014, it was actually very hard to move from, let's say you're in the Outlook mail team and you want to do deep learning. They'd say, well, we have a research group and you're not in it. So it was actually very hard. So what a lot of people needed to do in order to move from just doing this on the side and self-teaching to really steering their career in this direction was they needed to find a new employment opportunity. And so what the Silicon Valley Deep Learning Group rapidly became a place where people could explore new employment opportunities. And of course, that drew people who were personnel recruiters and such from various organizations, big and small. And a lot of people found opportunities in startups there. So often, even with the very speakers who were, talking about their startup, people would have time to talk to them and say, hey, I'm interested in doing this. So we have functioned very much as a kind of community builder, and a lot of things have happened. People have come, given a talk, hired some employees, and gotten an investment from investors who were there, in the same night, right? So there have been a lot of this kind of dynamic activity in the deep learning group that just comes from its heterogeneous nature. And that's drawn in more people of more diverse character. So it's been a really positive experience.
That's really cool.
Is Silicon Valley kind of a strong nexus for this field, or are there other parts of the country or the world where there's even more activity around deep learning?
I would say Silicon Valley is, if you include San Francisco as part of Silicon Valley, which I think we now all do,
Sure.
It is the nexus for this technology, I think, at this time.
I'm referring to, I've attended an event the last few years, the Machine Intelligence Summit in Toronto, Waterloo area. And it's just, it's teeming with talent and enthusiasm around the topic. And it seems worth checking out if you haven't been.
Oh, absolutely. I mean, there are other places where there's a great deal of work going on in this space. And Toronto and Montreal, there's a huge amount of activity. Of course, there's lots of activity in Boston and in Los Angeles.
Sure.
But still, I think, even despite all of that, the center of mass, I should also mention London. It's sort of impossible to miss the role of DeepMind in a lot of things that have happened in the last couple of years. So, but it's not just DeepMind. I mean, DeepMind comes out of a rich community that's in the London area. So there's people all over the world. There's many centers where people are doing this. There's many very important centers in China, for example, that are separate from the ones in North America. So this is a very rapidly emerging field. There's a lot of people who are very interested. And now in 2018, you can't really see the community as being centralized in any particular locus, right? This is sort of what's for dinner now, right? Like everybody is doing this. And of course, there are places that have a richer history. The Silicon Valley Deep Learning Group is older and bigger because it was founded in a place where this technology was emerging very early on.
Sure.
And we just happened to hit on a need which seemed to be very strong. So the group grew kind of under the force of that external need.
We kind of zoomed ahead to all this interesting work that you're doing in this field, but shuttling backwards a bit, you particularly have a really unique and interesting background, having gone to school very young and working in robotics and kind of emerging fields very early, and leading to this role at Magic where I think it was head of, quote, special projects, which is always an interesting title.
My original title was head of core software, which was, core software was basically the software that ran on the device as opposed to application software for the device.
Right.
So the software of the device as opposed to software on the device.
Sure.
I'm not sure that distinction is very easily made. But when I started at the company as head of core software, we were responsible for building the infrastructural software that would run the device. And then a separate team was responsible for things like applications that would run on it.
Right. Can you talk a bit more about your role there or some of the products that you worked on? I mean, just coming from the Stanford car, going to Magic Leap and building software, like we're all waiting for the AR VR revolution to kind of take place, and we're waiting for spatial computing to be mainstream. How close are we to actually seeing this in consumers' hands on the daily basis?
Well, I think at the moment, we have the luxury that Magic Leap has shipped their first product, so we can, wear it and play with it and see where it is. I think that, there's a lot of people in the world, they like to talk ill of things, sort of like to put down stuff that they didn't work on or whatever. And I think Magic Leap is, in some sense, unfairly the victim of a lot of sort of naysayers who just like to say bad stuff. The reality is this is version 1 of a product that has, many versions to come. If I were to hand you an iPhone 1 right now, you'd be really very unimpressed, right? So I think that it's really a matter of taking steps in a consistent way. I'm not really affiliated with the company anymore, so
Sure.
I'm not in a position to really say anything of any interest about whatever products are down the pipeline. But speaking broadly, looking at, products like the Xbox and the iPhone and the, I don't know, pick your favorite, the Microsoft Surface tablet, all of these things, when they come out, the first one, then, it's the basic idea and it sort of proves the point. And if people think the idea is worth pursuing, then there is a second product and a third product. And in time, they become quite good.
Right.
For people who might not be familiar with Magic Leap and what it's shipped, could you talk a little bit about the product and what you actually see, what you see it pointing towards?
Well, so the Magic Leap product is, again, I don't want to get too deep into this. The Magic Leap product is a wearable augmented reality device. And the idea is it's essentially a pair of glasses that you look through. And when we say augmented reality, there's now kind of a taxonomy of careful terms to describe all these different cases. But professionals tend to refer to a situation where you say, look through your phone and see an edited version of the camera view as mediated reality or something like this. And true augmented reality is one in which you see the world directly and clearly through a transparent display. And there's overlay that's added to that transparent display to give the impression of things in the world. Now, the difference between what Magic Leap does and what many people had done previously is a lot of previous work, like Google Glass, was focused on adding some heads-up display information to your environment, which might be useful, a map or a clock or something like that. But what Magic Leap is doing, what they term spatial computing, is largely about creating rendered images in that overlay, which give the impression of being three-dimensional objects that live in the three-dimensional world in a way that's convincing and compelling and useful.
Right. You mentioned a product from Google that by all mainstream opinions was kind of a colossal failure. I think by insider opinions was an interesting leap forward.
John, could you possibly be referring to Google Glass?
Yeah, potentially that product. I have as an analyst in the field and having played with all of this stuff over the years, I've enjoyed the pleasure of kind of putting things on my face and poking around and playing games. And there's been a lot of niche applications, particularly in gaming. But what are some of the possibilities for the non-technologist to think through or to be excited by in this VR, AR world that's useful and compelling and, not just kind of a demo or for game?
Sure. Well, okay, so this is a very subjective question, and I have my own opinions on this,
Sure.
and I'm not speaking for anyone else, let alone Magic Leap, but really anyone. In my own sense, I think that there's two things that jump to my mind always when I think about augmented reality. One of them is the actual habit we all have of sort of looking down at our phones, which is a terrible habit. It's socially obnoxious, and it often leads to crashing into things like telephone poles and palm trees.
Or other people.
Or other people in the worst case, yeah. So I think that it's very important to just think to ourselves about the disadvantage that some of the existing technologies have. And one of the things that augmented reality or spatial computing or wearable AR can do for us is just free us from some of the disadvantages we picked up along the way for technologies that we kind of know and love, like our cell phones. On the other hand, the other thing that really sort of comes to my mind is when you deal with the phone or other kind of computing, it's not private in any way. And so it's very easy for other people to not only see that you're interacting with it, but see what you're doing with it. And that also leads to kind of social awkwardness, right? So there's this classic example of just looking at a person and sort of seeing their name hovering above their head. It's so overused, it's become cliche, but frankly, I would benefit from it as much now as I would have before it became a cliche, right? It's a very useful thing. Even these little kind of tidbits that allow you to interact with the computing environment in a way that doesn't disable your social interactions with other people is extremely powerful to me conceptually. So there's lots of other things, of course, and there are games and there are weird little applications like sticking a clock on the wall in your office or whatever that are kind of have advantage. But I think the real value is creating a world in which we can rely on and draw from the kind of cloud or whatever you want to call the internet, the compute infrastructure of the world in a way that is not vying for attention against our social interactions with other human beings, but facilitating our interactions with other human beings.
How far away are we from a form factor that's not such a kludge on our faces? I've played the Star Wars game at Disney World 15 years ago, with a big visor on my face. And I feel like I've played similar games with modern technology in recent months even. So how far away are we from an actual thing that we can wear that doesn't impede the social interaction, but as you say, kind of augments and offers these tidbits about the world around us that's useful and smart?
I don't have a good answer for that question. I think that, there are lots of groups of people who are working on this problem in different ways. And depending on which of their technological approaches pans out more effectively, the distance from here to the time you describe could be as little as a year or as much as a decade. I think also that there's a lot of thinking in the community going into exactly what feature set really constitutes utility. Mm-hmm. So if you want to make something like Google Glass has low utility, but it's a small and not overly imposing form factor. We didn't talk about, we went by Google Glass in a moment, but obviously some profound errors were made in judgment about the human factors elements and the psychology of it. I don't quite see why everyone feels the need to put a camera on this thing. I don't think if anybody walks up to you and puts a camera in your face, I think that the natural response is to punch them, right? And so if you walk up to somebody,
or make a really awkward face,
or do something but it's really very annoying to have somebody walk up to you and here we're having a conversation that we agreed in advance to kind of have this podcast conversation, but to have somebody just walk up to you on the street and shove a camera in your face and start asking you questions, ask anyone in the entertainment industry who deals with this kind of paparazzi phenomena, it's infuriating.
Well, it's
right?
the problem of consent, right?
It is very much tied to that. It's tied to consent. It's also just tied to the fact that in reality, when you have an interview or you talk to someone on a video or whatever, then you're putting a lot of faith in the editors to not kind of edit things in a way that makes you seem particularly dumb. Right?
Sure. We'll do our best.
Or
show notes to Jim.
In the case of video, to sort of look particularly stupid, like in every politician that's been alive in operating in the last 40 or 50 years, you can find a picture of them looking exceptionally dumb, which is sort of heavily utilized by people in whatever group doesn't like that politician, right? So it's easy to take a video and freeze a frame where somebody's in the middle of speaking and their mouth is in some weird shape or whatever. So people don't really like being confronted by recording equipment in the hands of people they don't sort of know or trust, right? Because the editing power is too great. So I think when you have the idea of putting a camera on someone's face without even getting into the issue of people walking around in the bathroom with the camera on their face or whatever, it's very awkward. And so I think Google Glass made a number of sort of significant errors that were not technological, right? They were product design errors. And that's what kind of killed the product. But rewinding for a moment, the utility of a tool like Google Glass is quite high, and we could rebuild that tool today and it would be much higher still. And the form factor is relatively light and relatively non-imposing, and the technology now exists to integrate it much more deeply into kind of a glasses-like interface that would be visually not very intrusive. But those things don't supply a great deal of functionality, right? Magic Leap has been exploring kind of the opposite extreme, where spatial computing represents a huge degree of functionality, a tremendously rich medium for creativity and new applications and new ideas. But of course, it follows naturally that the platform that can support all of that is both a little larger on your head, and also, for example, in their current shipping device, there's a kind of a belt pack that you wear that holds other part of the computing, right? Kind of like an old Sony Walkman.
Like a puck
sort
of thing.
Yeah.
Or a fanny pack even.
Oh, not that big. Much more like a phone clip to your belt. It's not bad at all. Personally, I find many people are critical of it. I find that maybe I'm just old enough to remember the Sony Walkman, but having something clipped to my belt and a wire that goes to my earphones is sort of not that weird to me. The Magic Leap approach has been to really try to open the door to the richest possible environment and see what people do with it, right? Magic Leap's future success presumably will be driven powerfully forward if people find a lot of utility in this environment. And if they don't, then people will prefer a different kind of approach, a lighter weight kind of, a Google Glass-like device, of which there are many right now and more are coming.
Is there sort of a platform reliance on a developer community to spring forward and make all these interesting things for the product?
Oh, there certainly is. And a company like Magic Leap, part of why the company raised quite a bit of money and proceeded in the way they did was because it was a natural requirement to launch a totally new platform that they would need to have developers and a developer community. And, they just had a conference called LeapCon, I guess, which is kind of a developer conference. Sure. I wasn't there, but I read about it on Facebook. And, so they're very actively involved in fostering such a community.
So you yourself are very active in this community. When's the next Silicon Valley Deep Learning event? How can we attend or get involved or stay in the know?
Okay, so I wish I could tell you when the next event was. At the moment, the Silicon Valley Deep Learning Group is joining forces with 3 other community open source software projects. So the OpenCV computer vision library, which has some 25 million downloads at my last count, is something that I've been very heavily involved in, wrote some books on.
Right.
OpenCV, which was created originally by Dr. Gary Bradsky, and 2 other products, Open3D, which is kind of like OpenCV, but less focused on images and more focused on point cloud data, and something called CARLA, which is a simulation environment mostly used for automotive learning, right? So to actually simulate, you could think of it as, I'm not enough of an expert to give you the details on CARLA, but it is sort of Grand Theft Auto for deep learning agents or something like that. I'm still learning about CARLA. But OpenCV, Open3D, CARLA, and the Silicon Valley Deep Learning Group have joined into a single entity called the Open Source Vision Foundation. So OSVF is now the single 501c3 type organization that houses all 4 of those entities.
And what is the mission for that foundation?
So the mission for that foundation is actually very much related to the original mission of OpenCV, which is to build a common foundation for all of these technologies to advance together. So in the early days, when people were doing computer vision, let's say in the early 90s, if you were to go and visit some university and see who's doing computer vision at MIT or Stanford or whatever, you'd see that they had a long lineage of software that, graduate student after graduate student had worked on for decades. But when somebody would leave that university and say, take a postdoc at another university, they'd have to start with a completely new software base and relearn everything from scratch. And the implementations were very non-standard and non-portable, and it was very hard to compare things that people had done at one place with something at another place, and so on. So the basic idea of OpenCV was to recognize, this was Dr. Bradsky's insight, was to recognize that 90% of what all these people are doing is stuff that's kind of nobody's going to revisit it. Like it's building blocks that everybody else is giants on whose shoulders everyone is now ready to stand. And so at that time, OpenCV was an Intel project at Intel Corporation. So Intel's idea and Gary's idea was to build a foundation that everyone could use that incorporated sort of the best of all of these building blocks. And then once the community had decided that something was useful enough and not stable enough, then an implementation would be added to the library, and then everybody could climb on the shoulders of that. And this turned out to be extremely good. So I note that this is the All Turtles podcast, and you're probably familiar with the expression, it's turtles all the way down,
Indeed.
Right? But in this case, it's sort of turtles all the way up. Right? So each new turtle gets stacked on the last turtle, and then the elephant moves to the top of the top turtle. But this is a very effective strategy, and it's played an enormous role in the growth of computer vision as a topic, right? You can decide you want to do computer vision. I've talked to many people who made this kind of decision. They said, I think computer vision is cool. I want to learn it. So what do? They go and buy a book on OpenCV, watch some, podcasts or video on YouTube, and start writing code. And very quickly, because there's this common base that they can learn, they can start doing interesting stuff, within a few weeks or a few months, depending on their own level. So that was the idea of OpenCV. The idea of the OSVF is to essentially expand that concept to include more core ideas. Computer vision is very heavily involved now in 3D structure and structure reconstruction, mapping. We probably saw Google's discussion of their new sort of visual GPS localization tool. So, and it's used in robotics, and it's used in self-driving cars and so on. So the idea is to recognize that these other technologies, in the case of Open3D, that 3D structure data and the algorithms that naturally operate on 3D point clouds are now very closely tied to computer vision in practice because people are doing these things together. And then similarly, CARLA is involved naturally because the people who are so heavily involved in the vehicle self-driving industry and ultimately broadening to other robotics activities are using vision, using 3D.
Right.
And then the role of the Silicon Valley Deep Learning Group in that is also broadened because our original mandate was really deep learning as such. And now we broadened a little bit. Deep learning, of course, permeates all three of those other topics now, right? But also our Silicon Valley Deep Learning Group's mandate is broadened to include the things that are, if you like, legacy or coming in computer vision and 3D structure and so on that are coming from those other three elements.
Sure. Now, you're not just a community advocate. You have to be working on something in this field. Can you give us any hints into what's coming up next?
No.
Okay, great.
So this is my field. This is what I do. So I'm very actively involved in it. That's certainly true. But at the moment, I'm working on my own sort of quiet projects in the corner. So you'll have to stay tuned.
We'll have to stay tuned.
You'll have to let us know when you're ready to come out of the corner.
Adrian Kaehler, thank you so much for joining us. It's been a great conversation. We really appreciate your time. A lot of great stuff.
Yeah, thanks, Adrian.
Sure. Happy to be here. Thank you for inviting me.
Now it's time for us to share an AI use case with you, audience. I think, Jessica, you have something interesting you've encountered in the world in the last couple of weeks you want to share with us?
I feel like most of my AI use cases are like things that annoy me in the world that just happen to be infused with AI.
This is a great place to air grievances, so we should go with it.
Yes. So I was on my way to the airport a couple of weeks ago on my the beginning of my multi-city work trip tour, and I was late for the airport because I'm always late for the airport, and I don't have TSA pre-check or anything, so I've almost missed a bajillion flights in my lifetime. And I got stuck on Cesar Chavez, trying to get to the freeway behind a self-driving car.
Mm-hmm.
And Cesar Chavez, if any of you live in San Francisco or have been here recently, Cesar Chavez is in the middle of a quote-unquote beautification project where they created a giant median down the center of the road, which is sort of like a freeway in the middle of, the Mission, which is a neighborhood in San Francisco. And they've started putting trees into it, trees and plants and trying to make it a more beautiful and less eyesore of a street that runs through the, this neighborhood, this lovely neighborhood in the city. And the self-driving car, these spindly little branches from these little trees that they've planted were sort of poking out just the tiniest bit into the street. And the self-driving car braked at every single branch. So it was every 3 feet, it braked, right? And the thing that I've learned about this is that...
Which kind of car was it?
It was a Cruise.
Okay.
The thing that I've learned about this is that this is a defect or something that we haven't advanced far enough in feed forward neural networks, right? It's cars can't do double takes. They can't parse what's in front of them, see that there might be something there that they didn't expect, and then kind of go back and just register that one thing again. It's not part of the technology yet. And so what we end up with are these cars that are sort of scanning the area in front of them. But if they see something that's very slightly out of the ordinary, they can't return and parse just that thing. And so what you end up with is almost missing your flight to the airport.
They're also
or at the airport.
At least currently tuned to be much more kind of conservative than probably eventually they'll be tuned for.
Yes.
So
it's like driving behind a 90-year-old who
So shout out to Cruise for safety first.
Right.
Well, except braking all the time isn't necessarily great for safety for anything else. But
we've talked about cars a handful of times on this podcast, and I've recently become a motorcycle commuter in the Bay Area.
Kudos for safety.
Right. I wear a lot of protective gear, but my inclination, and I've spending a lot of time on the 280 and the 101, which are hellscapes for motorcyclists, as it turns out. But my inclination has been ride up and around the Teslas and the new Volvos and the new Acuras, all the cars where I can physically see the LiDAR, just thinking my safety is advanced because these advanced vehicles have these things, but there's multiple human elements at play. First of all, the entitlement of the sorts of drivers in the top of the line vehicles on the freeway. I've never been blown by, where I'm already going fast on a motorcycle, I've never been blown by like a Honda Civic. It's always a high-end Mercedes SLK.
Or one of those Volvos that half drives itself.
Right.
John, I used to work for a life insurance company doing actuarial data analysis, so I know what the numbers are in here.
Okay.
About 120% of everyone who rides a motorcycle dies in a motorcycle accident every year.
Great.
So your chances of being killed or injured on a motorcycle are roughly 120%.
You're going to die 1 1/5 times.
Yeah, exactly. It'll be terrible.
Well, I better make it count. We are going to take a listener question now. This one comes in via Twitter, and it's in response to an article on the All Turtles website, I think. So the question is, in response to one of your articles that mentions algorithmic bias, is there current research happening now on the effect of AI's bias on people?
No, that's a good question. There's a ton of it. There is. This is one of the kind of most actively talked about in research fields right now, in kind of the intersection of AI and policy. We did a podcast segment reviewing one of the research papers on this in season 1.
Yes, we did.
And there's been a bunch more stuff, and there's been several companies made too to both research this and try to make products that fix it. I just met with a really impressive startup a couple of days ago called Blendor in San Francisco, which is doing super interesting work about this. But what I've kind of started seeing as I've looked into this field myself is, there's a lot to be said about AI bias, but really a lot of what that research is uncovering is the various bias in humans.
And the humans who make the systems.
Yeah, and how that gets translated mostly unintentionally into the AI. And so it's almost not an algorithmic question. I think step one is to just have a better understanding of what human bias is. And then, before we can attempt to really make unbiased AI systems. And the other understanding is that unbiased isn't necessarily the goal. That's also kind of a weird way of phrasing it. So super interesting area.
But I think what we've realized that we're doing is we're baking unconscious bias into systems because humans are sort of riddled with unconscious bias.
Right.
That's one of several reasons, but yeah.
It sounds like great opportunities to make new things to work on this problem. Where are the areas where people are particularly biased? Something like hiring, for instance, even in the writing of job descriptions, there's certain language that appeals to a certain audience that leaves out a certain other audience. And there's a few startups working on this problem in particular, where Amazon's a customer of one of them, where all of their job descriptions are being rewritten by sort of a Grammarly-esque product.
Yes, we actually use this or at least my team does, for reviewing our own job descriptions.
As a gut check that you're using proper language.
Exactly.
That's awesome.
Mm-hmm.
There's a whole kind of topology, taxonomy at play here. At kind of the broadest level, bias isn't necessarily specific to bias against characteristics of people, right? There's all sorts of bias that we have that isn't necessarily good or bad.
Just is.
I may prefer the color blue in a way that I just don't even know about to the color orange because, maybe I had a baby blanket that was blue and I've somehow imprinted on it or something like that. And that's obviously not necessarily bad for society in any way. To the extent that could be detected, it could influence my decisions, my behaviors. It might actually be used against me in influence campaigns. So nefarious or not, related to gender or race, right, or other kinds of people identity or not, it's an interesting thing to understand. And AIs can bake in that kind of bias as well. They may have nothing to do with what we would consider fairness or unfairness. It's just it is more disposed to make decisions in certain ways for reasons that the creators don't understand and the AI itself doesn't quite, quote unquote, understand. And then there's all of these things that, bias against people, against certain protected characteristics of people, race or gender or ethnicity or anything like that, which I think when people talk about inherited bias, they're mostly talking about that, as probably they should, because it's the sharpest point of the problem. But the research I've seen around this really says it's a more fascinating and deeper problem than most people thought even 5 years ago. If I was just starting in college right now, at some intersection of computer science and philosophy, which is mostly what I studied in undergrad, I think that's what I would focus on. I think I would specifically focus on computer science and philosophy with an understanding of cognitive bias, how it applies to people and how it applies to AI. It's a fascinating and field that will become much more important in the next generation.
So TLDR to the great listener question, the answer is yes. With that, we wrap up another episode of the All Turtles podcast. This podcast is a production of the All Turtles worldwide media empire. We recorded this episode in the glorious Donatello Studios in San Francisco, California. Thanks to Adrian Kaehler for joining us this episode and letting us pick his brain about computer vision, and for sharing how his foundation is getting disparate deep learning groups together. If you have any questions, comments, or suggestions for future episodes, send us an email to hello@all-turtles.com or tweet us using hashtag AskAT. Thanks to everyone who made this episode possible, including Jim Metzendorf for editing, Marie McCoy-Thompson for production supervision and editorial management, Chris Blug for his audio expertise, Micah Rivera for our artwork, and Matt Ammerman for our theme music. On behalf of Jessica Collier, Phil Libin, and yours truly, John Cifuentes, and the rest of the All Turtles team, thanks for listening.